Assalamu alaikum guys, my name is Wasim Mawri. Today we will be learning how to create a stunning linked list in C language and in maths. But before I actually proceed with the programming of a linked list, I would like to tell you what the linked lists are all about. A linked list is a dynamic data structure. Dynamic in the sense that the memory is allocated and deallocated dynamically. Uh, there are n number of advantages of linked lists over the arrays. It's very easy to insert elements into the list, and the same is the case with the deletion as well. So the linked list consists of collection of nodes. Every node has two parts, the data part and link to the next part. There's some disadvantage in linked lists also, because some sort of memory is wasted for the pointer field. But believe me, linked lists are stunning, and we'll be programming it right now, right there. Thank you very much. So guys, we will be programming our linked list. We'll be creating a structure something like that, with head pointing to the first node and ptr pointing to the last node. So let's program our linked list in C with header file is on the top. You are familiar with the header files I have actually written. So I will introduce another kind of header file. It's a clip.h. And basically this header file contains the definitions for the malloc and raylog, klog, free. We'll be creating our structure something like that. I will be naming it hint node, so it'll be easy to remember the types of things. So in our structure we'll be having two fields. One's called data field and another is called struct node stop next, and it's called next. Linked lists are also called self-referential structures because of that very fact. It refers to itself. I create two pointers, namely as head and ptr. So our main program will be calling two functions: create to create the linked list and display to display the elements in the list, and obviously cat ch to hold the screen after the display of the items. I'll be actually defining the prototypes of the functions that neither returning anything nor they are taking anything from the called program. There we go. So we'll start. First of all, we will define a variable, and then we will define a variable of type struct node, and we'll be giving a message to the user: enter data, and we'll be receiving that very information from the user using keyboard. It will be obviously of integer type and %d. No memory is allocated for the temp variable, so in order to allocate memory to it, we'll be using malloc function, and we'll be allocating the memory of size struct node, and obviously it is going to return address. The address will be converted to something, the struct node address. So I will be allocating, we'll be assigning the data to temp of data is equal to d, and temp of next. That memory check will be containing data, and in the next field null. So we created something like that, a node with two fields. First one is containing data. Assume the data to be for example 10, and assume the link field contains null. So we'll be checking if head is equal to null, and we will assign the address of that memory chunk to the head, also to the ptr also, and second time when this function will be called, create function, to create another node. First the node will be created like that, something like that, with data, okay, and user will be entering some data, for example 20, and we are assigning null to this. Okay, well, actually what we have done, we actually created 2 pointers, namely as head and ptr, with both head and ptr containing the address of the first node. Assume it 100. Sorry, assume the address of the first node is 100, and assume the address of the second node to be 200. So we actually created 2 nodes, but they are not linked together yet. Let me link them. Since ptr is pointing to the first node, we'll be using the else part. Head is not null, so the condition is not true. Control will come here and will be telling something like that, ptr of next is equal to temp. Okay, so what I have done here, I will show you. ptr जिसको पॉइंट कर रहा है, ये 100 को पॉइंट कर रहा है, उसके नेक्स्ट में डालो टेम्प का एड्रेस जो अभी अभी नया क्रिएट हुआ है. सो वी आर एक्चुअली इरेजिंग दिस, और हम बोल रहे हैं ptr of next is equal to temp, since temp is this one, and we are saying ptr of next is equal to temp, means putting the address of the newly created node 200 to ptr of next, and we will be updating the ptr as well. Ptr is equal to 10. That's it, we are done. So the creation of the subsequent nodes will follow like this. So what I have done here, we are also updating this, we are putting 200 here, and when the create function is called for the third time from the main program, something like that, create, I would show you. It will come to here. First of all, it will declare a variable, declare a temporary variable, sorry. So it will be receiving a data, then it will create a node, something like that. There we go. It will be having 2 fields, and it will be putting some sort of data in the first field. Sorry. Assume that the data is 30, and in the next field there we have null, and assume its address to be 300. Okay, since these 3 lines executed, first we allocated the memory, then we assigned the data, when we assigned the null to the next field, the control will come here. Head is not null, it will go to the else part. ptr of next, I will show where the ptr is. ptr is pointing to 200. we are saying ptr of next, यानी कि ptr जिसको पॉइंट कर रहा है उसके नेक्स्ट में डालो temp, जो नया नोड क्रिएट हुआ है. सो एक्चुअली इरेजिंग दिस, ये जो नेक्स्ट वाला पार्ट है ptr ऑफ नेक्स्ट, ptr यहाँ से यहाँ पॉइंट कर रहा है, और हम बोल रहे हैं, मैं ऐसे दिखाऊंगा लाइन से, ptr इसको पॉइंट कर रहा है. हम बोल रहे हैं ptr ऑफ डेटा ये है, ptr ऑफ नेक्स्ट ये है, ptr के ऑफ नेक्स्ट में डालो टेम्प, यानी कि नया नोड. सो हमने यहाँ पे 300 डाला. ओके, 300, एंड वी आर एट द सेम टाइम दूसरा जो हमारा स्टेटमेंट है ptr is equal to temp, we are also erasing the contents of ptr, we are updating it to point to the newly created node that will act as a last node now. So it is 300. Similar is the case with the other nodes as well. So we are done, I think. So we can create a function, namely as display, in order to display the elements in the list. Display, okay, So we'll create a temporary pointer called t, let it be, and we are assigning the address of head. So t will be pointing to the first node. We will say while t is not equivalent to null, जब तक t में null नहीं जाएगा तब तक आप चलते रहो. So we'll be printing the data t of data first time. T is pointing to this, and we are saying t of data. It will print this, and we are supposed to actually advance our pointer to the next in order to point it to the next location. So we'll say t is equal to t of next. Now t will contain 200. We are saying we are saying t is equal to t of next. For example, let's assume that we create actually t. T was containing 100. T was containing 100. We said in the first statement that print t of data. So t of data is 10. It printed the 10, and then we said t is equal to t of next. t जहाँ पे point कर रहा है उस वाले next में जो data है वो t में डालो. So we are updating the t at the same time to 200. Now t is not pointing to this. T is actually now pointing to this. Getting me? So third time, t is not equivalent to null. T is containing 200. We are printing t of data, and we are saying t is equal to t of next. T is containing 300. So it's pointing here. We are printing the data t of data, and t is containing null. Now the program will stop. Okay, so we'll check it out whether everything is good. So we'll save our program. So save is, I will save it as basic ll.c, basic linked list.c. I will execute our program, compile and run. Assuming everything is good, struct, oh, I forgot to mention struct node. So we'll execute it again. Enter data, let it be 1, enter data 2, enter data 3, and we have our data here. So let's beautify our program. We will not actually call our function like this. Create will be declaring a variable called choice, and then we will be having a loop do while choice is not equivalent to say 0. Okay, so we will say printf 1 to enter data /n, 2 to display, and 3 to 0 to exit, 0 to exit, and then we'll be saying enter your choice. Okay, we're receiving our choice in a choice variable, ampersand choice. Then we will say switch choice. Okay, case 1, and we'll be creating our create function, and then break case 2, it is display. Okay, it is brag, and case 0, it is exit 0. It actually is a function used to exit from the program. Its definition is in a header file known as process.h. So we have successfully created our list. So we'll actually erase the here. So assuming that everything is good, let's execute our program again. Enter your choice. 1 to enter data 1, 1 to enter data 2, 1 to enter data 3, 1 to enter data 4, 1 to enter data 5, 1 to enter data 6, 2 to display. So 1 2 3 4 5 6. or it's not actually clear, it's not actually visible. Let me actually modify my program to some extent /n, and we will be actually putting some sort of space in between the elements. I will be giving a message as well. We'll be saying like this, printf the data in the list is as under, okay, /n, and we'll be running our program again. Oh sorry, compile and run. Oh party, sorry, syntax error. F11, 1, data 1, data 2, data 3, data 4, data 5, data 6, data 7, data 8, data 9, data 10. Then we will display our program. Display the contents in the list. Contents in the list 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and we'll be exiting our program by giving the choice as 0. So that's it. You can actually copy the code, or you can actually execute it on our own systems, and give your feedback so that we can improve the quality of our video tutorials as well. Thank you very much. Assalamu alaikum.